So now we're going to take a look at how you can add vectors together. So we're going to add them together using a picture. And it's called the tip to tail. So essentially, the tip and the tail of two different vectors align. They get added to each other. So the tail of the second vector, so here's my first vector, the tail of the second vector is added to the head of the first vector. So this is what it's going to look like. And what's left when you're done doing this is called the resultant. Oftentimes we'll dash it in. So this would be called the resultant. And it tells you the result or which direction your vector, your one in blue, would be traveling. So if I had a vector, let's just say it's movement, and I'm moving this direction, and somebody comes along and pushes me, my end result would be in this direction, and it would make me faster because they're pushing me. Okay, so this is called the resultant. And it's the result of adding two vectors together. So let's just draw a picture and see where our trig would come in here. So we have a plane moving 240 kilometers due north. So we're looking at our north, south, east, west. So due north says my plane is headed this direction. I'm not going to draw it to scale, okay, but I'm going to label it. A wind is blowing 10 kilometers per hour due east. So we have to make sure that we know that this is due east. 10 is much shorter than 250. Again, I have not drawn it to scale. So if I was headed due north and something was pushing me as I was flying, hopefully you would agree it would move me off course. And this would be my resultant. Notice that the resultant is connecting the two ends. And you can tell, hopefully, that this resultant, okay, and remember how we write it, this resultant is the hypotenuse, so it's going to be longer. That wind was pushing me and forced me to increase. So if I wanted to find the resultant, I could do that by saying I have a squared plus b squared equals c squared. So I would have a squared plus b squared equals the resultant squared. So if I take the square root of that, and I'm not too worried about that value, I'm more concerned that you can find it. The next thing that we would need to do is find direction change. Would you agree that this would be theta, the direction change, and that would be the tangent inverse because I know the side opposite, tangent TOA. I know the side opposite of 10 is 10 and the side adjacent is 240. Notice the plane increased, and so that would be the hypotenuse. So it would find me how much it blew off course. And you could plug that into your calculator. Again, I'm not too worried about finding the values, more like what are we going to be doing here. Okay, and this is physics, so I'm just trying to give you an introduction. Okay, let's try this one. A plane is moving 300 due north with a wind blowing 100 kilometers south of west. So if you are south of west, okay, so I like to put like a little north, south, east, west here. And so this is west, so I'm south of west. And boy, this is a pretty strong wind. Okay, and it should be 1/3 the size of this, which obviously it's not to scale. Okay, the resultant then, my plane would be forced off course in this direction. And it kind of looks like I have a headwind, so I can visibly compare this 300 to my resultant. I'm going to call it, sorry, not the magnitude, it is the resultant. So I can see how long that is, and visually it shows me that it's shorter. So if I really wanted to find this value, I could not use a squared plus b squared equals c squared. Okay, so I'm going to pull this 300 out in front here instead of being inside. I think I would know this angle here. Because it's south of west, this is a 45. So this angle here would be 45. And I could use the law, if you remember the law of cosine. So I could find this value, my resultant squared would be each side squared. So I'm just using my law of cosine. If you want to finish this off, you certainly can. Okay, and I'm going to put in a 300, and it's going to be cosine of 45. So that's really why we learned the law of sine and cosine for these kinds of situations. So I think I can already find that my change of direction is equal to this value, but remember your change of direction would be this angle right here. This would be my theta. My plane was pushed off course, so I would need to find theta. So I could not use SOHCAHTOA. It's not a right triangle, but I believe I could use maybe the law of sines if I had this value. So I think I could use the law of sines. And again, I'm not asking you to do that. I just want you to be aware. So this is just a brief introduction to some things that you're going to encounter that we've been doing in trig that are going to be related to your physics course.